We've all seen the tutorials. You define a few Python functions, wrap them into ToolNode, and suddenly your AI agent can talk to your database or send emails. It feels like magic, but in production enterprise environment, that magic is a massive liability. In my last video, I spoke about the CISO's perspective on agentic risk. Today, we are getting under the hood. As engineers, we can't just talk about governance. We have to build the code that enforces it. I'm going to show you three specific technical fixes to secure your LangGraph tool calls using Pydantic validation and human in the loop interrupts. The first mistake developers make is trusting the LLM to provide the right arguments to your tools. If your tool takes a user ID as a string, an attacker might use indirect prompt injection to pass a SQL injection payload or a different user's UUID into that string. The fix is Pydantic. In LangChain and LangGraph, you should never define a tool without an args schema. In the highlighted example, I have given the user ID, UUID, a field description, which is a must valid UUID v4. The query limit is defined as greater than equal to 1 and less than equal to 100. And again, I have given a description over here. Now have a look at the line number 7. When I'm defining that tool, I'm defining the args schema, where it is taking the input the same class secure query schema. By using UUID4 and constraints like greater than equal to 1 and less than equal to 100, you are creating a semantic firewall. If the LLM tries to pass drop table as the user ID, the tool node fails before it even touches your database logic. Some actions are too risky for an LLM to take alone, like deleting a cloud resource or executing a bank transfer. In LangGraph, we handle this with breakpoints. In 2026, the modern way to do this is to use interrupt function. Have a look at the example on the screen. The definition sensitive tool node has a state and we have a feedback which is the interrupt function. Whenever the action delete server is taken, it is going to interrupt and wait for the feedback to get approved. When the graph hits this interrupt, it saves its state to a checkpointer and stops. It waits. Your front end can then show a approve or reject button to a human admin. Once they click it, you resume the graph using graph.invoke. This ensures that for every nuclear action, there is a human signature in the logs. Finally, stop giving your agents global admin keys. If your agent is supposed to summarize emails, the API key you give that tool should have mail.read permission and not mail.send. As a senior architect, I recommend building wrapper tools that handle the authentications internally. Don't pass raw tokens to the LLM. Instead, have the tool fetch a short-lived scope token from your identity provider, like OAuth 0 or AWS IAM, right before the execution. This limits the blast radius. If your agent is compromised via prompt injection, the attacker is still trapped within the narrow permissions of that specific tool. Securing AI isn't about one magical tool. It's about defensive coding. Before you move your agent from a notebook to a cluster, Check these three checkboxes. Are all tool inputs validated with Pydantic? Are all write actions protected by a human in the loop interrupt? And does every tool use the principle of least privilege? Grab the code from my GitHub repository. The link is in description. If you want to see how these concepts tie into a larger enterprise strategy, make sure you watch my CISO's guide video in the description again. In the next Tiny Tech Talk, we are going to look at AI SOCs, how to monitor these agents' logs in real time. I am Amit, and thank you for building securely.